scrubbers and how they help CEMS, that is, continuous emissions monitoring systems, with lower operating costs. So originally, our ammonia scrubbers were designed for our Nafion-based sample conditioning systems, where they take out the ammonia to protect the Nafion dryers in our sample conditioning systems. But we found that they are very useful for traditional CEMS systems using coolers, because they can protect your system by reducing the amount of unwanted chemical reactions and thereby lowering the overall maintenance costs, and also protection against catastrophic failures. And in this presentation, we're going to explain that precisely. So ammonia slip is the unintended consequence of SCR, which is selective catalytic reduction, which is the reduction of NOx by injection of ammonia or urea in the exit gas from a plant. Could be a power plant, could be any type of plant burning fuel where you want to reduce the amount of NOx emissions. Could be coal, could be oil. Ammonia slip occurs when unreacted ammonia is released into the flue gas stream. So there's a number of causes from this. First of all, the added ammonia is never entirely consumed, and actually most of the time you want to err on the side of a little bit too much to make sure that you reduce those NOx emissions as far as possible. You can also have the catalyst temperature that are running not in the optimum range, or just simply too much ammonia is used. Many times there is a sensor in the system and a feedback loop that shows how much ammonia needs to be injected, and sometimes those sensors are simply off and too much ammonia is sent up along with the flue gas. So the range of ammonia slip is typically 1 parts per million to up to 200 parts per million, but typical measurements are around 5 to 20 parts per million. The release of NH3 or ammonia might not be regulated or even reported. Unfortunately, the analyzer shop doesn't always control the rate of ammonia injection, so there's little that they can do about it. Process operators are often not concerned about ammonia slip, and excess ammonia can damage downstream components, which we'll explain a little bit later. Let's look at the 3 unwanted consequences of ammonia slip. So number 1, NH3 or ammonia is a catalyst in the formation of SO3 from SO2 and O2. So as vapors condense, you can get SO3 plus H2O equals H2SO4. So what we want to do is eliminate that sulfuric acid that can form downstream in your sample stream. You don't want that sulfuric acid to eventually hit your analyzer, especially in the instances where your cooler might fail. Number 2, NH3 plus H2SO4 is NH4H2HSO4, ammonium bisulfate ammonia salts. These can occur due to sulfur content of the fuel source. It is white and powdery when pure. It forms large rhombic prisms as it condenses. It collects and fouls solid surfaces in flues, probes, filters, sample lines, and inside analyzers. It forms in tight spaces where, for example, an oxygen analyzer paramagnetic mirror. So this is also an issue. A lot of times sample lines get clogged and create havoc. So having excess ammonia get into your sample lines can produce lots of issues, lots of service issues. Number 3, conversion of NH3 back to NO. This is especially with high temperature converters, but can also happen at lower temperatures. This can ardly inflate NOx readings. When every ppm counts, this can cause a failed RADA. Are you paying for NOx but not NH3 emissions? So that's another issue. So what's the solution for this? The solution is to install an ammonia scrubber for your cooler-based system. An ammonia scrubber can protect analyzers and downstream components by eliminating ammonia salt deposition. The ammonia scrubber has a very selective reagent. So basically what you have is we have this phosphoric acid that is basically coats these saddles, ceramic saddles, inert saddles in the scrubber. So there's a high surface area. And when your sample gas comes into your ammonia scrubber, all of that surface area with the phosphoric acid will cause the phosphoric acid to react with the ammonia, leaving the rest of the items you want to look for intact. The devices themselves have a very high corrosion resistance. We have two types of housings available. There's a stainless steel and a polysulfone version. The element is H3PO4 on inert ceramic. They are reliable and are low maintenance. They have no moving parts, only periodic refills, which refill depending on how much ammonia is in your sample stream. So here's a flow schematic here. Both your sample inlet and outlet are at the top of the ammonia scrubber. The sample goes through the inside core and then flows back up through the saddles and media. Then there's a final stage filter, and then you have your sample outlet at the top. So our target temperature to run these scrubbers is around 80 to 90 C. The ammonia reacts in vapor form, and the water remains in the vapor form. Otherwise, the bottom fills with liquid. We also have the heated version with a blanket to maintain a temperature of 90 degrees C. Or the temperature can be maintained to 80 to 90 degrees C in a heated enclosure. The phosphoric acid anhydride reacts with water, then forms ammonium phosphate salts on inert ceramic. So here's a sample installation with a cooler. The sample line feeds first to the ammonia scrubber, then to the cooler. You need to add water if installed after the cooler, because the sample is so dry. So actually we have a number of customers that install the ammonia scrubbers both before the cooler and after the cooler. They're effective insurance policies, because a lot of times the coolers will fail catastrophically, and what you don't want is to have any of the raw sample gas loaded with ammonia form reactions and hit your analyzer. That can ruin your analyzer. The rebuilding or cleaning of the analyzer can be many thousands of dollars. So these ammonia scrubbers pay for themselves multiple times over. As more and more people find out about them, they're being installed more often. So here's what spent ammonia scrubbers look like. First of all, on the left, the scrubber, this is an example of what not to do. The scrubber should be mounted horizontally, should not be mounted horizontally as this one was. On the right, here's an ammonia scrubber that was mounted vertically. So just to go over on our final slide, the maintenance of an ammonia scrubber. The media has a life with it. The media lasts for 40,000 liter parts per million hours. You just hand tighten the mounting screw and you can remove, or you can loosen the mounting screw and you can remove the holder where everything is kept. But let's look at how we can calculate the amount of hours the ammonia scrubber is going to work. So if you have a flow rate of 10 liters per minute and you have 5 parts per million, you can calculate that you can change the media every 33 days. Now, some of our customers change it every 2 weeks, some of them change it every 6 months. It all depends on the amount of ammonia that you find in your sample stream. In any case, the product pays for itself. We supply the media replacement. It's very inexpensive, and we recommend that everyone that is using a sample conditioning system with a cooler and has even the slightest amount of ammonia in the sample stream should be installing an ammonia scrubber to improve their system reliability and lower their costs, especially in case of catastrophic failure of your cooler. Thanks for listening.